S1, Chapter 2, Lesson 5. So our last lesson for radicals is Dividing Radicals Part 2, where we focus on rationalizing with a denominator that's a binomial, which makes things a little more difficult. So we have two things down here. So we have to figure out how to rationalize that, what's the purpose of rationalizing again? Why did we rationalize? Get rid of the radicals. Nope, you're right, yep. To get rid of the radicals. Okay, and then what is the little piece that we talked about in lesson 3 with multiplication that we noticed it did? What was that word? It started with a C. You saw it in your quiz. Conjugate. Yeah, the conjugate helped us get rid of radicals. Remember? We did those multiplications and we saw, oh, the middle cancels. Oh, the middle cancels. And so we only had the numbers on the outside and the radical stuff canceled. So that's how you do this. So in order to simplify this in binomial form, we multiply the top and the bottom by the conjugate. Now, the first one's going to seem easy. The second one's where it gets a little bit messy. Okay? So I did root 5 plus root 3 to top and bottom to do the conjugate of what's on the bottom. Now, I will do this one time, but I will not do it every time because we need to trust it. We're smart. The bottom, again, will FOIL out to root 5 times root 5 is 5. Root 5 times 3 is plus root 15. Negative root 15. Negative 3. So those cancel. We simply have 5 minus 3. 2 is our bottom now. Okay, so I FOILed that out. Okay, and I'm just showing you that this will happen every time. We do not need to do this. So essentially, it's going to be root 5 minus 3. Change a little bit here. We'll talk about it, just because they're not both radicals. Is everybody comfortable with that? So the bottom's 2. The top is just going to be 2 times these guys. That's all we can do. 2. But actually, what I would do is, if I was you, I wouldn't do it, because what's going to happen to the 2? Cancel. So your answer is just root 5 plus root 3 in this case. Okay, that's your simplest it can go. All right, and then B gets a little messy because we have a binomial on top. So you will need to FOIL the top. So conjugate still, root 6 minus 2, root 6 minus 2. This right here, we should know. Root 6 on root 6 is 6. 2 times negative 2 is negative 4. Good. So the change there is the 2's do multiply because they're not radicals. So it's a 4, not just a 2 like it was in the first one. Okay? This one here, we do have to FOIL. Root 6 on root 6, 6. Negative 2 root 6. Negative 2 root 6. See, they don't cancel here. That's why we have to FOIL it. Negative 2 times negative 2 is positive 4. And now we just simplify. Okay, I'll pause there for a second. Any questions on that? Right. 10 negative 4 root 6 over 2. 6 plus 4 for the 10. Negative 2 and negative 2 is a negative 4 root 6. All over 2, which we can simplify a little bit further, can't we? Because a 2, 10, and 4 all have a 2 in common. So what happens is the last piece here, the 2 goes to here, and the 2 goes to here. So it's going to be 5 minus 2 root 6. Any questions with that? So it is a little messy because you have the binomials here. Okay, biggest thing with these is be organized, and like, yeah, just being organized is kind of the biggest thing on these. Okay, this one here, 1 plus root 6, or root x, excuse me, not 6, goes to top and bottom. The top's a 1, so that's cool. So just 1 plus root x is all that's on top. The bottom will be what? 1 minus x. 1 times 1 for 1. Negative root x is just x. There you go. That's the simplest, yep. All right, just got a couple more. Like I said, this is the most commonly thing missed in radicals. That you will see this on assessments. I almost asked the conjugate question in almost every one. Okay, I want you to be able to do that, just because it's really organized and it tests a lot of things. Can you FOIL? Can you simplify? Are you comfortable with fractions? It kind of hits a lot of objectives. Okay, so this one here, what am I going to multiply the top and bottom by? 4. Yeah. So it says express the whole number in the denominator. So we're going to do root 8 minus root 3 over 4 root 3 minus root 2 times 4 root 3 plus root 2. 4 root 3 plus root 2. There's my conjugate. Okay, let's do the bottom first since that's a little bit easier. The bottom here, this is where it gets a little tricky, the multiplication, okay? So pay attention. 4 times 4 is 16, right? Our multiplication. Root 3 times root 3 is 3. So you write 16 with a 3. Negative root 2 and positive root 2 is minus 2. So your bottom here is going to be 48 minus 2. So 46 is the bottom. And now we're going to do the top. So the top, root 8 times 4 root 3, that's going to be 4 root 24. Root 8 times root 2, that's going to be root 16. I like that. Negative root 3 times 4 root 3, I like that. That's 4, that's a negative 4 times 3, because the root 3's go away. And then negative root 3 times root 2 is negative root 6. So this is where we're at. So we're going to break the 24 down and simplify the rest. 24 goes to 4 times 6. That comes out as a 2. So this guy is 8 root 6 now. I'm just going to write that here so we can see it. Okay, this one is 4. This one is minus 12. This one's minus root 6. This kind of just skips you having to rewrite the whole thing. 8 root 6 minus 1 root 6 for 7 root 6. 4 minus 12 for negative 8. All over 46, as far as we can go. That is your simplified expression. Square root of 16 is the number 4. Yeah. So we wrote a 4 right above there. Okay, anything else? Okay, so we get a little bit uglier one here. Oh, nice save. Okay, so area of the trapezoid given by the formula of area equals 1/2 height, base plus base. A and B are the two bases of the parallel sides, and h is the shortest distance between the two sides. So just remember, trapezoid is this shape here. Okay, this is the height, this is A, this is B. This is what they're talking about. Okay. So it says if the area of the trapezoid is 20, okay, well they told me the area formula is this. Oops, did not write B first. A plus B. Okay, and so then we know the area they told me is 20, so that goes here. So 20. So the parallel sides are root 6 and root 5. So that means I have 1/2 h root 6 plus root 5, because that's what my A and my B are. Determine the exact distance between them. So they're telling me to solve for what? For h. Good job. They're telling me to solve for h. Okay? And then it's actually like, whenever this stuff kind of happens, guys, don't just think that this is some random math problem. What are we probably going to do here? Use the conjugate. Yeah, we're going to be using the conjugate. We're going to be simplifying that expression using the conjugate. Okay? So kind of expect that. Sometimes people look at this, I have no idea what I'm going to do. Well, you're probably going to use the conjugate at some point. Let's just start thinking that. Okay? So how would you isolate h? Let's just start with isolating h. What's the first thing you would think to do?
Divide 20 by 1/2.
Yeah, divide 20 by 1/2 or times by 2. That's the same thing. But yes, I would times the 2 to both sides. Are we okay with that? So we are going to be at 40 equals h times root 6 plus root 5. Now what? We don't want to divide h.
Times 40 by the conjugate of 6.
No, not yet. We want to isolate h. Huh? No, Jules? No? Yes, it's no. Not yet. This stands for h what this stuff? Divide it over. Right? To get rid of it, divide it over. So we're going to divide the root 6 plus root 5 over, and then now you see the problem. There's your conjugate we're going to need. See? So then we have h equals, so you have the answer, but the answer is not in a nice simplified form. That's why it says here, answers with a rational denominator. Okay? Answer with a rational denominator. So don't forget what rational means. Math 9, I know, a long time ago. What's rational mean? It's a very actually simple definition. What does rational mean? Okay, that's the more complicated definition. It's even simpler than that, but you're right. Terminating or repeating decimals is a rational number. That's correct. But simply, rational numbers can be written in fraction form. Anything that can be written as a fraction is a rational number. So like, for example, and we'll talk about this because it's important for you guys to know this. I know you guys forget. You have your number system. You have rational, and then we're going to say we have integer, we have whole, and we have the little natural here in the middle. Okay? So the point with this is that an integer is any positive, negative whole number, right? Can the number 6 be written as a fraction? Right. It can be written as 6 over 1. That makes it rational. Okay? Radicals are always going to be irrational because when you do radical 6 with your calculator, it's not going to be repeating and it's not going to stop. Okay? Now radical 4 isn't because radical 4 is a perfect square. Okay? But when it says rational, my point to you is they're telling you no radicals. That's what that means. No radicals. We want to be able to have like nice whole numbers. Okay? So, off that tangent, sorry. Root 6 minus root 5, the top and bottom is the point. Here. I would not distribute the 40. There's really no need to. I would just leave it as a product on top. So I would just leave it as 40 times root 6 minus root 5 like this for now.
Can you write it as 40?
You can write it as 40 squared.
Like 40. Because that does not equal.
Yes, you can distribute the 40 if you want. Right. I don't like when you get higher math. It's better to keep things as products in case they can cancel. So like right here, this is going to be 6 minus 5, which is just 1. So nothing's going to happen. Yeah. So this is actually, I think, cleaner to write it like this, Rieger, but if you put the 40 in, it wouldn't be wrong. Okay, so that is your simplified expression there. All right? Any questions?
Do you then have to put that
To
to mixed radicals?
mixed radicals, like distribute?
Yeah.
Yeah, so I was telling him that's kind of a cleaner way of writing it because it's you factored out of 40 because they both have 40 in common, but if you distribute the 40 in, it's still okay. Okay? All right.